Hello everyone, my name is Qingyue Li and I'm a PhD student at Universitätsmedizin Center Rostock. In this video, I will demonstrate how motion signals can help us understand disorientation in older adults using a controlled virtual state environment. This work is part of CombiDiag project supported by the EU Marie-Curie actions. At the crossings, even a small moment of disorientation can matter. For older adults, navigating everyday environments can be especially challenging, particularly at crossings, where working, deciding, and orienting happen all at once. At this moment, the person tries to move forward, but gradually loses direction, hesitates, and finally stops, unsure where to go. Now let's take a closer look at the same situation. If we replay this journey, we may notice something important happens. The body begins to respond even before the person is fully aware of being lost. Changes in movement, working speed, and physiological signals can already be observed along the way. As a person continues working, these signals evolve. And when disorientation becomes clear, the patterns look different. These subtle changes may offer early signs of difficulty, not just of getting lost, but of the increased demands that wayfinding places on the aging body and mind. However, outside the lab, wayfinding is far more complex. Crossings are crowded with cars, cyclists, pedestrians, and traffic signals, creating both noise in the signals we measure and challenges for older adults navigating the environment. This complexity can easily become overwhelming. To address it, we turn to a virtual city, a controlled environment based on real-world maps. Here, crowding and distractions are reduced, allowing participants to navigate realistically while we capture meaningful motion and physiological signals. The virtual city is presented in a laboratory setup, with participants working on a treadmill surrounded by a 270-degree immersive screen. Within this controlled setting, motion and physiological sensors allow us to capture meaningful signals with greater clarity. Sensors are attached to different parts of the body, with a focus on the lower limbs. Their signals are received by both cameras and dedicated sensor systems, allowing continuous, real-time monitoring of movement. Participants are supported by a safety frame and wear a harness for protection. Once they are ready, an operator presents a map showing a predefined route with step-by-step instruction at each crossing. Starting from the start point, participants should follow this path towards the end point. As the task begins, participants work through the virtual city while multiple sensors move with the body, capturing detailed motion signals. On the local computer, the data becomes visible in real time, showing working patterns, changes in ground contact, and acceleration signals as the participants move. When participants look around, hesitate, and search for direction, the distinct changes in signal patterns unfold. After the laboratory experiments end, all recorded data are synchronized into trajectories. These trajectories are then transferred for further analysis. By identifying which signal changes are most informative, we aim to predict disorientations more reliably and automatically test these findings in the real-world environment to support the development of real-time assistive devices. This project is still ongoing, and we hope it can eventually help older people. Thank you for watching. If you have any questions, please feel free to contact me at the email address shown here.